Hello, Algebra 2 Geo students. This is hopefully going to be kind of a short lesson. There's only a couple of concepts in here. Areas of triangles and some specific quadrilaterals. Quadrilaterals are shapes with four sides. You may be aware, but if you're not, that's what they are. This is a shape with four sides. It's called a rectangle. This is a shape with four sides. It's called a square. Area of a rectangle. Let's say we call this length here, maybe call that the base of the rectangle. Maybe call this length the height. Area of a rectangle is quite simply the base times the height. That's it, base times height. Doesn't really matter which is the base and which is the height, but we usually say the horizontal one is the base. That's just kind of standard. And for square, the difference is that the base and the height are equal, so maybe we'll call them S, like for side, like the side of a square. And the area of a square is the same. You do S times S. It's like base times height, but it's called, in this case, we usually say S squared. The reason that this is called squared is because it's how you find the area of a square. That is not just a coincidence. That's really why we call it that. So you may already know those, in which case, hooray. If not, now you've learned something today. Moving right along, we have this shape, which is known as a parallelogram. Parallelograms are quadrilaterals where the sides are parallel, but the angles may not all be right angles. This is a parallelogram, but all the angles are right. This one is a parallelogram where the angles are not right. Technically, they're both parallelograms, but whatever. So if we look at a parallelogram, we imagine again that this side is the base. Now we have to, the height's not a part of the shape. We have to draw it. Like you drop a vertical line straight down. Then we would call this length here the height. It's like the vertical height. It's got to, you can't use one of these angled lines. You got to go straight down for the height. And if you do it that way, the area of a parallelogram is also base times height. As long as you're using that straight up and down height, it's base times height. In the area of a triangle, like this is kind of a demonstration to show you why, but the area of a triangle is 1/2 base times height. You can see that if you divide this parallelogram up into, you draw a line here, divide up into two different triangles, the area of this parallelogram is still, if we think about this as the height, and this is the base, like that works. This is the same, the parallelogram, the opposite sides are the same length, which means this is also B. And then this is also H. And maybe you can see that these two lines are the same length. So you get 1/2 base time, you get base times height for this one and one for this one. So like you basically, the area of each one of these triangles is half the area of the parallelogram. Area of the parallelogram is base times height. Area of a triangle is 1/2 base times height. So the only thing that's important to remember here really is that this H here, let me redraw that arrow because that's garbage. This H here is a vertical height. It's got to be the vertical height or else it doesn't work. And now area of a trapezoid. This is another shape. Trapezoid technically is a quadrilateral that has exactly one set of parallel sides. So you can tell that this side is parallel to that one. And in a quadrilateral, we call these parallel sides, we call them the bases. This one feels more like a base because it's on the bottom, but from a mathematical point of view, the bases are these two sides. They're the parallel sides. The bases are the parallel sides. These two sides are not the bases. They're sometimes called the legs, I think, but they're not. These are the bases. Those are not the bases. And if again, I imagine dropping a vertical line down from the top to the bottom, this vertical line here is again the height. And maybe, so I have a name for it, I'll call this length here, I'll call this one B1 for like base 1. And I'll call this distance here B2 for base 2. So like the two bases, we just call them base 1 and base 2. It doesn't matter which is which. I just named them 1 and 2. And the area of a trapezoid then is 1/2 times the height, again, the vertical height, and then times the sum of the bases. So it's, I don't know, like all these things have base times height, and some of them have a 1/2 thrown in there. But basically the idea here is that there are two triangles you could imagine in this thing. And the area of one of them is 1/2 times h times b1. And the other triangle is 1/2 times h times b2. And so to get this, to get the area of the whole trapezoid, you add those together. And that's what this is. But it's 1/2 times the vertical height times the sum of the two bases. That's it for a trapezoid. We're really just crushing this, aren't we? So this is like, I would call this like kind of a complex shape. It has many different pieces to it. So find the area given that this RSTU, that this shape here is a parallelogram. That tells me some things. Like for example, it tells me that I know that the opposite sides are equal, which means if this is 35, then this length right here is also 35. And if this is 25, this length is also 25. I'm not sure I'm going to need that, but it's good to know. So I would think of this as like, there's like 3 areas. There's like 1, 2, and 3. A triangle, a trapezoid, and another triangle. Oh, sorry. Triangle, a parallelogram, and another triangle. So maybe I'll start with this triangle. I know that the height of this triangle is 20. And I need to know this distance, which I don't know right now, but I could find it using the Pythagorean theorem. I'm going to call this length here VU because it starts at V and ends at U. And since this is a right triangle, I can say that this squared plus whatever this is squared equals this squared. Pythagorean theorem, 20 squared plus VU squared equals 25 squared. Then you do some math. This is 625. This is 400. So I get VU squared is 225, which means VU is 15. So that makes this side 15. And that's enough to find this area, which we'll do in a second. For this parallelogram, I know the base is 35, but I don't know the height yet, maybe. That's h. I know the area of this thing is base times height. So it's 35 times something, but what is h? Well, if you go over here, you can see that this segment here from R to V is the same length as this one. That's like a straight down, straight down. This is a straight line, which means that whatever this length is, this is the same length. So this h is going to be 20 also. So now I know the base and the height of this parallelogram, so I can find its area, which I'm going to do in just a second. Now I have this other triangle, which I got to find the area for. And I need vertical heights and bases. So like maybe you're like, well, if this is the base, then this is the height right here. I don't really know how to find that distance though. So I'm not going to do it that way. I'm going to imagine that this is the, maybe this is the base here. I'm like kind of thinking of looking at it at an angle. This is the base, 28, then this distance is the height. And I know that that's going to work because they're at right angles to each other. Like this is vertical compared to this one. Just so we kind of know what I'm talking about, I'm going to redraw this triangle here like this. I just kind of like, I twist this a little bit. I put W still down here. I put W. I put U up here and I put T over here. UW, I don't know. I know WT is 28. I know from T to U is 35. Then I can do the Pythagorean theorem again here. 28 squared plus UW squared is 35 squared. Then you like math this up a little bit, and I'm pretty sure you get that UW is 21. So this is 21. 21. So now I can find the area of this triangle too. I can add up on the area of the figure is going to be the sum of all 3 areas. So let's just calculate, like put them together real quick. Let's see, for this first triangle, I'm going to have 1/2 times base times height. I'm going to write a total for the total area. So for this one, I do 1/2 base times height. So it's 1/2 times 15 times 20 plus the area of the parallelogram is just base times height. The base is 35 and the height is 20. And then for this triangle, remember this is the same as this triangle, I just redrew it over here. That's 1/2 times base times height because it's a triangle. It's 1/2 times 28 times 21. 1/2 times base times height. And then you could punch this into your calculator, or you could just kind of think about it. 1/2 of 20 is 10, and 10 times 15 is 150. 35 times 20, well, 35 times 2 is 70, so add a 0 and you get 700. And I want that to be bigger than this, and it is. That's convenient. Then 1/2 times 28 times 21, this is probably less obvious, but it's 14 times 21, which is 280 plus 14, which is 294. Then you sum all this stuff up. It's like 1,000, 1150 minus 6. I think it's 1144. And just, I'm going to punch in my calculator just to confirm. 0.5 times 15 times 20 plus 35 times 20 plus 0.5 times 28 times 21 is 1144. So I was right. And there are no units, so I don't have to put any units. I'm going to break this just so that it's not super long, but I don't think the rest of it's going to take too long. So stay tuned.